Hello, hi everyone. Welcome to the Student Brand. This is your Swa sir. Today we are going to discuss about electric current. Electric current, CBSE Grade 10 Physics. Okay, so electric current is nothing but the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, so let's start. Electric current. Electric current I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. Okay, so to this video, can I get target 1000 likes? So 1k likes. So please help me in that. So I need 1000 likes to this live class. So those who are watching, please help me in that. Okay, so try to click on the like button. So let me reach 1000 likes to this live class. Okay, just click on like button. Okay, so be a part in that to receive my goal, to reach the goal. Okay, done. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, so here you can see. So I am taking Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. So this is the coulomb. And the SI unit of time is second. 1 ampere equal to 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, so 1 ampere is defined as 1 coulomb of charge. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. I hope it is very clear. So 1 ampere equal to 1 coulomb per 1 second. Let me reach. So help me in that to get 1000 likes to this live class. Just click on like button. So okay, just click on like button. So I need to reach 1000 likes. That is the target. Okay, so please click on like button, help me in that. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Okay, so now you can see, so charges are moving inside of the conductor. So we can't say only one electron is flowing, charge is flowing. Only 2 electrons flows, we can't say current is flowing. Only 3 electrons flows, we can't say current is flowing. Number of charges are moving in the conductor. Then only we can say current is flowing. Okay. So yes, students. So I need 1000 likes for this live class. Will I get or not? So it depends on you. Please click on like button. So help me to reach 1000 likes. Okay, so help me in that. So click on like button, make me to reach to the target. So 1 ampere equal to 1 coulomb per 1 second. So that is our target today. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. If charge only 1 electron flows, we can't say current is flowing. Only 2 electrons flows, we can't say current is flowing. There are many number of charges are moving, so number of electrons are moving, then only we can say current is flowing. Yes or no? Current is flowing. So that is nothing but quantization of charge. Quantization of charge is nothing but q equal to plus or minus ne. Q equal to plus or minus ne. Plus or minus ne. On one electron, how much charge is present? On one electron, how much charge is present? We'll see. On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb. In one coulomb, so 1 by 1.6 into 10 power minus 19. So help me children, help me students. So I need to reach the 1000 likes. So within half an hour, 1 hour I am taking. So 1 hour target. Within 1 hour I have to reach 1 hour target. 1 hour class. 1 hour live class. So within 1 hour I have to reach the target. So let me reach the target. Just click on like button. Okay, just click on like button. So make me to reach the target. So on one electron, 1.6 into 10 power minus 19 in 1 coulomb. So 1 by 1.6 into 10 power minus 19. Okay, so if you are saying, if you are getting, that is, so 1 by 1.6 into 10 power 19. If you solve this one, you will get 0.625 into 10 power 19. 0.625 into 10 power 19. So that is 1 coulomb if you are taking. So 6.25 into 10 power 18 electrons are present. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so in 1 coulomb, 6.25 into 10 power 18 electrons are present. Understood? So I equal to Q by T, 1 ampere equal to, so SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So children, I need to reach the target. Please help me in that. Just click on like button. So within 1 hour I have to reach the target. Just click on like button. Okay, so make me to reach the target. So Q equal to plus or minus Ne on 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power 19. That you will get, okay, so 0.625 into 10 power 19. Then I'll get in 1 coulomb 6.25 into 10 power 18 electrons are present. Okay, so that's enough. That is about electric current. Now we'll discuss about electrical elements. Just click on like button, students. So I need to reach the target. So help me to reach the target. So I have this target to reach within 1 hour. I have to reach the 1000 likes. So let me whether I will reach or not. So make me to reach the target. So make me to win in the, okay, so running race. So just click on like button. Those who are watching the channel, please click on like button. So within 1 hour I have to reach the target. So let me reach. So click on like button. So now I am considering here. Now I am considering electrical elements I have to take. So electrical elements. First one is cell. So I am taking this the cell. Positive terminal, negative terminal. This is a cell. And the next one is battery. This is a battery. Positive terminal, negative terminal, battery. And the next one is, third one is switch. Open switch. So I'm concerned this is the open switch. Okay. Next one is closed switch. This is the closed switch. Okay. Closed switch. And coming to the fifth one is resistor. This is the resistor. Resistor is a device which is used to Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Okay, so rheostat, next one, rheostat. Rheostat, this is a rheostat. Rheostat. Rheostat is a device which is used to regulate the current without changing the voltage source. So I have to reach the target of 1000 likes within 1 hour. Okay, children. So students, those are attending the classes, just click on like button. Click on like button. So let me reach to the target. Reach to the target. Actually, so we can take like this also. Fuse. Okay, so like a wire. And coming to the seventh one is ammeter. So this ammeter. And coming to the voltmeter, this is a voltmeter. And the next one is ninth one, wire joining. And the next one, wire crossing. And 11th one is the bulb. Okay, so this is a bulb. So dear students, so I want to reach the target. Please help me in that. Click on like button. Those who are watching, just click on like button. Just touch like that. Okay, so I can reach to the maximum number of students at the same time. They can learn. So I within 1 hour, within live class, I have to reach the target. So let me reach the target. Please click on like button. So I want to know. So cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter. So this is the wire joining, wire crossing, and this one is the bulb. Understood? So this is the bulb symbol. Now we will discuss about electric circuit. So problems also we will discuss. Problems also. Okay, so let's start. Electric circuit. Here. So a closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. So I am taking this a bulb. And the next one I am connecting the ammeter. Next one I am connecting the battery switch. Okay, so here I am considering positive terminal, negative terminal, current is flowing like this. Okay, so current is flowing, ammeter, right? So now you can see. So here conventional current is there. Conventional current, and second one is electric current. So conventional current and electric current. So conventional current is nothing but the flow of positive charges. The flow of positive charges is known as conventional current. So the movement of positive charges we can say conventional current, and the movement of electrons is known as electric current. Okay, so here you can see the flow of positive charges. So this is positive charges, and the flow of electrons will be considered as electric current. And here you can observe here. So positive charges are moving from high potential to low potential. Whereas electrons are moving from low potential to high potential. Okay, so electric current. So electrons are moving from low potential to high potential. Understood? So conventional current is nothing but flow of positive charges. So positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Understood? So this is about conventional current and electric current. Conventional current and electric current. I hope it is very clear, right? And so one more point. So here is one question. So electrons will flow only positive terminal to negative terminal positive terminal. So electrons will move only negative terminal to positive terminal. So children, so students, so please click on like button. So reach my target. Make me to reach the target. Make me to reach the target. I have to reach 1000 likes within 1 hour. So click on like button. Please click on like button. So make me to reach the target. Okay, so next one. So we'll discuss about one more. That is electric circuit is completed. Potential difference. So we'll discuss about potential difference. Potential difference. Okay, potential difference. Potential difference. Potential difference. Potential difference. Okay. So potential difference is nothing but potential difference is nothing but, so I need to reach the target 1000 likes. So please make me to reach the target. Just click on like button. So I'm asking all the students. So just click on like button. Make me to reach the target 1000 likes. Today live class target is 1000 likes. So click on like button. Make me to reach the target. Okay, I'm requesting everyone. Just click on. So coming to potential difference. Potential difference is nothing but, so I'm taking this a point and this point A and point B. So point A to point B. We are doing some work. We are doing some work. So thank you so much. So please share to everyone. Click on like button. So subscribe the channel. Those who are really want to support me, just click on the like button. Share to everyone. Ask your friends to join to the class. So make me to reach the target. So just click on like button, make me to reach the 1000 target. So those who are there in the live class, just everyone, if you click on like button, I can reach the target. So I'm requesting all, just click on like button to reach the target. Right, coming to the potential difference. Potential difference, work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor. So V equal to W by Q. V equal to W by Q. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. So 1 volt is defined as, oh, thank you, Anshu. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. Is it live or recorded? Yeah. So 740 6740. I'm here only. So I hope you entered now only, right? So it is not pre-recorded. It is live class only. I am here. So please click on like button. So if you like it, I want to reach the target 1000 targets. So 1000 likes. So please click on like button. Share to everyone. Inform to everyone. Ask them to join to the class. Okay. So 6740. Please click on like button. Share to your friends. I need to reach the target. So that is very important. So today live class target is 1000 likes. And coming to the concept, potential difference, work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. Okay. So V equal to W by Q. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, so next one we can go for electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from infinity to the required field. So work done to bring unit positive charge from infinity to the required field is called electrical potential. Electrical potential. So I am taking this positive charge. So I am taking this positive charge. It is at infinity. This is the required field. This is the required field. So we are doing some work. We are doing some work to bring unit positive charge from infinity to the required field. So V equal to W by Q. V equal to W by Q. That is electrical potential. Electrical potential. Understood or not? Electrical potential. So what is potential difference? Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is called potential difference. Coming to electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field. Okay, so I hope it is very clear. So this is about potential difference and electrical potential. Potential difference and electrical potential. So now we will discuss about Ohm's law. So coming to Ohm's law. Ohm's law. So Ohm's law is nothing but, so the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current at a constant temperature. The potential difference is directly proportional to the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. So V is directly proportional to I. V equal to IR. So coming to the materials required. Materials required. Okay, what are the materials required? First one is okay. First one I can say. First one, 4 cells of 1.5 volts each, of 1.5 volts. And coming to the next one, nichrome wire is 0.5 meter. And coming to the third one, ammeter, and coming to fourth one, voltmeter, okay, voltmeter. And coming to the fifth one, switch. Coming to fifth one is switch. And the sixth one is connecting wires. Okay, connecting wires. So you can observe here. So materials required. What are the materials required? You can observe here. Oh, thank you so much. Please share, do like, share and subscribe to Student the Brand. Inform your friends, ask your friends to join to the class. So thank you so much. So V is directly proportional to I. V equal to IR. Materials required 4 cells, 1.5 volts of each. Nichrome wire 0.5 meter length. And ammeter, voltmeter, switch, connecting wires. And see the 1, 2, 3, 4. So here I am taking ammeter, and next one nichrome wire, switch. So current is passing V across. So here you can observe. So those who are watching, please click on like button. So make me to reach the target. So here you can see 1, 2, 3, 4. Okay, current is passing. Current is passing like this. So current is passing. This is a nichrome wire, 0.5 meter length. So 4 cells. So 1.5 volts each. 4 cells, 1.5 volts each. Okay. So first you have to connect one cell. First one, connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. Repeat the process for 3 and 4. Understood? So you have to repeat the process for 3 and 4. Then you can observe. So first you have to connect one cell and observe the reading of ammeter and voltmeter. And connect two cells. What is the so connect to two cells and note down the reading of ammeter and voltmeter. Okay. And next connect three cells and note down the reading of ammeter and voltmeter. So and mention in the tabular form given below. Okay. So you can check once here. So I'm taking like this here. So 1, 2, 3, 4. Okay, so 1, 2, 3. Okay, serial number, number of cells, and ammeter reading, voltmeter reading, V by I form, that is R. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so if you draw the graph, okay. So if you draw the graph for VI, the graph is straight line for ohmic conductors. So V on Y axis, I on X axis. Okay, so the graph is straight line for ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductor. For ohmic conductors, the graph is straight line. For non-ohmic conductor, the graph is curve. Okay, so you can see here, I am taking like this. So the graph is curve. V on Y axis, I on X axis. Understood? So the potential difference across the ends of the given metallic conductor, is directly proportional to current flowing through it at constant temperature. V is directly proportional to V equal to IR. Metals required for 4 cells, 1.5 volts of each. Nichrome wire, ammeter, voltmeter, switch, connecting wires. Okay, so these are the materials required. After that, connect one cell and note down the reading of ammeter and voltmeter, and connect to two cells and note down the ammeter and voltmeter reading, and mention in the tabular form given below. Okay, so after mentioning, if you draw the graph for VI, the VI graph is straight, so straight line for ohmic conductors, so curve for non-ohmic conductors. I hope it is very clear. So what do you mean by ohmic conductors? Ohmic conductors are nothing but the conductors which obey Ohm's law. So those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. Okay. So if you like the concept, if you like my explanation, please click on like button. So make me to reach the maximum number of audience. So maximum number of students. So this is about Ohm's law. Next one. So we'll discuss about resistance and resistivity. Resistance and resistivity. resistance and resistivity. Resistance is nothing but so the phenomena of opposing the electric current. Resistance is nothing but the phenomena of opposing the electric current. Okay. So here you can observe. So R is so resistance is here. Resistance and resistivity. Resistance and resistivity. Resistivity. Okay. So resistivity you can observe. So resistance is the phenomena of resistance. Resistance is the phenomena of opposing the electric current. Resistivity. So resistance of the conductor per unit length and unit cross sectional area. Unit cross sectional area. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. Okay. So here R equal to rho into L by A. R equal to rho into L by A. So that is about resistance. And coming to resistivity, resistivity rho equal to resistivity you can see rho equal to RA by L. So RA by L. SI unit of resistivity is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancel. Ohm meter. So resistivity is equal to ohm meter. Resistivity is equal to ohm meter. SI unit of resistivity is ohm meter. Very very important. SI unit of resistivity is ohm meter. Very very important. So they will ask in the exam for so 2 marks question. So 2 marks they will ask. Okay, so this is for 2 marks. 2 marks. Understood? And see here you can observe resistance is depends on temperature and resistance depends on nature of the material. Nature of the material. Nature of the material. Nature of the material. And coming to the resistivity, resistivity depends on temperature. Resistivity depends on temperature. So you can see resistivity depends on temperature. And the second one is so nature of the material. Nature of the material. Nature of the material. I hope it is very clear. I hope it is very clear. So check once. Resistance is resistance. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So R is directly proportional to L by A. Okay, R equal to rho into L by A. So rho equal to RA by L. Rho equal to RA by L. So SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. So resistance depends on length of the conductor, area of the cross section, and resistance depends on temperature, and resistance depends on nature of the material. Coming to resistivity, resistivity depends on only temperature and nature of the material. Understood? Resistivity does not depend on physical conditions. This resistivity does not depend on physical conditions. So physical dimensions we can say. Physical dimension that is nothing but length and area. I hope it is very clear. So this is about difference between resistance and resistivity. So if you like the content, if you like this concept, so if you don't have any doubt, just click on like button. Okay, so make me to reach the target. So that is about resistance and resistivity. And coming to the next one, so resistors are connected in series combination. So resistors are connected in series combination. Next one, resistors are connected in parallel combination. Resistors are connected in series combination. Next one, resistors are connected in parallel combination. Let's start. Okay, resistors are connected in connected in series combination. Series combination. Resistors are connected in series combination. Okay, so here you can observe all resistors are connected in series combination. So how it will be? So before starting the topic, just click on like button. So let me reach the target. So those are watching. So one resistor, two and three. So this is R1, R2 and R3. So that I am taking V1, V1. This is V2, V2 and coming to V3. So R1, R2, R3. So I'm connecting here like this. Okay, and that is connected to the battery. So connected to the battery. So here you can observe. So I'm taking this ammeter and here battery. So I'm taking the battery here. So current is passing like this. So dear students, let me reach the target. So help me to reach the target. Just click on like button. Click on like button. Make me to reach the target. Here you can observe. So current is passing like this. So here entire the circuit. So all resistors are connected in series combination. Resistors are connected in series combination. Yes or no? If resistors are connected in series combination, current is same throughout the circuit. So that's why is equal to I1 equal to I2 equal to I3 equal to I. Current is same throughout the circuit. Current is same throughout the circuit. So but potential difference is different. So V equal to IR. So Vs equal to V1 plus V2 plus V3. So I am taking IRS equal to IR1 plus IR2 plus IR3. So I am taking common R1 plus R2 plus R3. So I can get cancelled. So I get cancelled. The remaining values are, so RS equal to R1 plus R2 plus R3. Okay, if n number of resistors are connected in series combination, RS equal to 2R. RS equal to so NR. RS equal to NR. RS equal to NR. So if you don't have any doubts, if the concept is clear, so click on like button, then I can understand. So you are understanding the concept, you are listening the concept. So it is, so no doubt in the concept, I can understand. Please click on like button if you like the concept, if you don't have any doubts. Okay, so if you like the explanation, so please click on like button, then I can understand, then I can go to the next topic. So make it fast, students, make it fast. Those are there, just click on like button, make me to understand. So you got the concept, so no doubts in that. So once again here, so R1, R2, R3, so three resistors are connected in series combination. So current is passing. So throughout the circuit, current is same. So Vs equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. II get cancelled. So RS equal to R1 plus R2 plus R3. So if resistors are connected in series combination, so RS equal to R1 plus R2 plus R3. So if n number of resistors are connected in series combination, RS equal to NR. Okay, so now resistors are connected in parallel combination. Parallel combination. So guys, so I have to reach the target. Okay, so 1000 likes. So I am right now at 26 likes. So I don't know how far it goes. Okay. So if you click on like button only, I can reach to the maximum number of students. At the same time, you can reach the target. Okay, so few people are saying so I may not reach, but you can do that. Okay, so you can make me to reach the target. So click on like button, share to everyone, ask your friends to join to the class. Okay, share as many as possible, as soon as possible. So now live class is going on, right? So make me to reach the target. So resistors are connected in parallel combination. Resistors are connected in parallel combination. So now you can see, so 1, so 2, and next one 3. Okay, so that you can observe. This is ammeter, so battery, so switch. So you can see here, so R1, R2, R3, R1, R2, R3. So three resistors are connected. So three resistors are connected in series parallel combination. So I'm taking here. So here that is potential difference V. So current is I1, I2 and I3. I1, I2, I3 current is passing here. So in this combination, you can see in this combination, potential difference is same. Potential difference is same, but current is different. Potential difference is same, but current is different. That is Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same, but current is different. Current is different. Understood? Current is different. So we know V equal to IR. So I equal to V by R. I equal to V by R. Understood? I equal to V by R. So now you can see here Vp equal to, so IP, because potential difference is same, right? So now we'll go to the current. Current IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. So that is nothing but V by RP equal to V by R1 plus V by R2 plus V by R3. So shall I take V common? So if I am taking V common, V I am taking common 1 by RP equal to, so V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So V get cancelled. V get cancelled. So shall I take 1 by RP equal to, the final formula is 1 by RP equal to, so this is 3. So here 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so if n number of resistors are connected in parallel combination, so 1 by Rp equal to n by R. So Rp equal to R by n. So if you like the concept, so if you like the explanation, so just you can click on like button. So click on like button. So just click on like button. Okay, like, share, and so I hope it is very clear. Next one, so check once again. So potential difference across R1, R2, R3 same, current is passing. So potential difference across R1, R2, R3 is same. So current is passing is different because across R1 I1 across R2, I2 across R3, I3. So current is Ip equal to I1 plus I2 plus I3. V by Rp equal to V by R1 plus V by R2 plus V by R3. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination. So 1 by Rp equal to n by R. Rp equal to R by n. Understood? Yes. Next. Which one will win? Hard work or talent? Both means you can do both. Like and subscribe to the channel. Okay, done. So I'll see. So I'm doing hard work. So if it is talent or hard work, you decide and do it. So that's enough. The resistors are connected in parallel combination. Now heating effect of electric current. So V equal to W by Q. So W equal to V into Q. So power equal to rate of doing work. That is nothing but VQ by T. So we know Q by T. What is Q by T? Current. So Q by T is nothing but current. That is nothing but I. Q by T is nothing but I. Okay. So I hope it is very clear. So that is Q by T is, that is electric current I. And so now you can see P equal to V into I. Then so E equal to P into T. Then we can say, so H equal to Vi into T, that is nothing but IR into I into T. So that we can get I square RT. Heat produced in the conductor, is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. I hope it is very clear. Okay, so you can see here V equal to W by Q, V equal to W by Q, W equal to VQ. So the rate of flow of charge is called current. So P equal to W by T, VQ by T is VQ by T. That is nothing but Q by T is I. So V equal to P equal to VI, E equal to P into T. So heat produced in the conductor is H equal to VI into T. IR into I into T, that is heat produced in the conductor, is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is about heating effect of electric current. Heating effect of electric current is also known as Joule's law of heating. Joule's law of heating. Understood? So we'll do problems. Let's start the solving the problems. So few questions related to electric current. Okay, so let's start. So find is it hard work or talent? Just click on like button or subscribe button, which one you are going, just go through it. So find the resistance of a conductor. Find the resistance of a conductor if the electric current flowing electric current is flowing through it is so 0.35 ampere when the potential difference potential difference potential difference across it is 1.5 volts. So answer to the question. So guys, choose one option. So let me know. Hard work. If you go for hard work, click on like button. If you go for talent, you can subscribe. So just click on and let me know the answer. Those who know the answer, you can let me know the answer. Just check once. So I'll give 2 minutes time. By writing only 2 minutes it takes time. So subscribe and like, share and subscribe. Like and share and subscribe. Yes, my answer is 4 ohm is correct. So very good. Welcome to the class. New. Yes, ma. Answer is 4 ohm is correct. So very good. Welcome to the class. Okay. So I'm doing hard work or it is talent. So let me know. If it is hard work, click on like button. If it is talent, subscribe. Okay. So now you can see here. So they given this is the current. I is given 0.35 ampere and the potential difference is given 1.4 volts. So we have to find out the resistance. V equal to IR. V equal to IR. Understood? R equal to V by I. Now you can let me know. So how much you got? So what about remaining students? Hard work or talent? So let me know. So your feedback is very important. Which one you are going for vote? So here you can see V equal to 1.4 by 0.35. So here 100 by 100. Then I'll get R equal to 140 by 35. 4. So R equal to 4 ohm. This is the answer. If you like the concept, if you like the channel, if you like my explanation, so subscribe. Do like, share and subscribe to Student the Brand. Subscribe. Live class will go on continuously without any stoppage. Check once. So I'm expecting 1000 likes. So we'll see I will get or not. So that depends on you all. So I'll write one more question. One more question. So answer this question. So answer me whether I am doing hard work or talent. So if it is hard work, like. If it is talent, subscribe. So I need to reach the 1,000 likes in this live. So help me in that to reach the target. Okay, let's solve the problem. The answer is, here you can observe so in a series electric circuit components made up of metallic wire ammeter reads. So that is current I equal to 100 milliampere. So that is nothing but, so let it be, no problem. If the length of the wire is doubled, so we know R is directly proportional to L. So if length is doubled, resistance also will become double. Okay, so resistance will become R1 now. R1 is R, R2 is 2R, R2 is 2R. Okay, R2. R1 is R. Initial resistance is R, final resistance is doubled. So if it is touch double length. Okay. So now you can see here, we know from Ohm's law V equal to IR. I is inversely proportional to R. So because we have to take this one. Okay, so I1 by I2 equal to R2 by R1. So there are initial current given, how much? 100 milliampere by I2. So equal to R2 how much? 2R by R. RR get cancelled. So I2 equal to 100 by 2. That is 50 milliampere. The answer is 50 milliampere. Ma. So if you like the content, if you like the explanation, so you can let me know in the response of like, share and subscribe. So do like, then I'll get to know. So you got it, you understood. Just click on like button if you got it. Once again I'll explain, check once here. So here current is given. Length of the wire is doubled. If length of the wire is doubled, automatically resistance also will become double. Okay, so R equal to rho into L by A. So length is double, area of the resistance. So by that we can take here. So here you can observe. So V equal to IR. I is inversely proportional to R. I1 by I2 equal to R2 by R1. 100 by I2 equal to R by RR get cancelled. Then you'll get I2 equal to 100 by 2, 50 milliampere. I2 equal to 50 milliampere. Is it correct? If it is correct, if you got it, just click on like button and we'll go to the next question. Shall we? Next one. So one more question. Answer to the question. Okay, so coming to the question, the answer is, so not tell, I will solve and tell. After solving, I will let you know. So here you see a 6 ohm resistance. So you have to check a 6 ohm resistance wire is doubled on itself, calculate the resistance. So actually R equal to rho into L by A, that is 6 ohm. Now, so this is the length of the wire. Initial length is L, area of the cross section is A. So it is doubled on itself. So the question is, so if you are taking this the wire, okay, so if a straight wire, if it is doubled on itself, so means it is folded all like this. So doubled on itself in the sense it is folded like this. It is folded like this. Understood? Once again. So if it is placed like this is a straight wire. Okay, so like this. So if it is doubled means it is folded on it. Okay, so then you can check once here. So I am taking like this, it is folded like this. Understood? So that is L by 2 length will become half, area become twice. Length will become half, area will become twice. Why? It is become, so this whatever you observe, so you can see, so this length will become half. Automatically area increases, right? Yes, so that's why now you can see R dash equal to rho into L dash by A dash. So rho is not changing. So rho is rho L. So no changes. But L dash equal to L by 2, A dash equal to 2A. L dash equal to L by 2, A dash equal to 2A. So then R dash equal to, so rho into L by 2 into 2A. So then you'll get R dash equal to, so rho into L by 2 into 2A. Then you'll get R dash equal to 1 by 4 rho into L by A. Okay. So by that you will get the answer. That is, we know this one, what is that? 6. So R dash equal to 6 by 4. That is 3 by 2. That is how much? R dash equal to 1.5 ohm. This is the answer. If it is, if you like it, so you can click on like button. So let me know you got the answer. Check once again. I'll explain. A 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. So this is the length of the wire, doubled on itself, folded on itself. Length decreases, area increases. Rho is same because metal is not changing. So that's why, so R equal to rho into L by a 6 ohm, R dash equal to rho into L dash by A dash, R dash equal to rho into L by 2, 2A. So 1 by 4 into rho into L by A. Then you'll get the answer. So R dash equal to 6 by 4, that is 3 by 2. Then you'll get R dash equal to 1.5 ohm. Is it correct? So if it is, if you like the content, you can click on like button, no? So if you don't have any doubts, if you like the concept, if you like my explanation, subscribe. Thank you. So next question, I'll give next question. Wait some time. Let's try one more question. So this is the question. So when resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. So when you are taking V equal to IR, so according to Ohm's law, you can check. Okay, normal wire is there. Normal wire is there. So you know the activity. So did you observe the activity? So factors. Resistance depends on the what are the factors? It depends on resistance. So like length of the conductor, area of the cross section. So you are taking the R L length wire. Okay, L length wire you are taking. So that time some current. If you are taking double of the length. So resistance also will becomes, okay na? Resistance also increases. So then current decreases. So with that relation we are taking that one. With that relation, if they mention stretched, okay, so if it is stretched, extended, so that time it's different. Here, so you can see factor depends on resistance. So I hope you once read that activity. Factor depends on resistance. L length of the wire, for that resistance will be different, but based on the current. So ammeter reading, voltmeter reading, ammeter reading you have to observe. So if you are taking double of the length, okay. First L length you have to observe the reading of ammeter, and you have to take double of the length, and still you have to observe the reading of ammeter. So it vary. Okay. So in that case, if length is increases, if length of the wire is increasing, okay, compared to the, so one each other. So one is length, another one is double you are taking. That time what happened? So what is happening in the circuit? Resistance is increasing. How much? Double compared to previous one. So that current is decreasing. So with the help of activity, we are taking that one. Understood? V equal to IR. V equal to IR from Ohm's law. According to Ohm's law. According to the factor depends on resistance. Once see that activity, so it is anyway it is there in the textbook. Once go through that. So if they mention particularly in the question, okay, so wire is stretched to double of its length, or this type of question, wire is previous one, wire is folded on itself, wire is folded on itself, that time different conditions. So with respect to area of the cross section we'll be considering. Okay, So once you read the question carefully, then you have to attempt the, so you have to answer to the question. You have to read the question, so twice or thrice, then you have to answer. Understood? So if you like it, so you can click on like button and share and subscribe. So remaining students, those who came now, so just if you like the content, if you like the explanation, please do like, share and subscribe to Student the Brand. And now, so let me know this answer. Let me know. So how much is the answer for this question? How much is the answer for this question again? So I'll give 4 minutes time. 4 minutes time. 4 minutes time. 10, 10, 10, 10, 10, 10, 10. So click on like button if you like the content. 4 minutes time. So 18 Coulomb is correct answer, ma. Very good. Keep it up, Ritesh. So very good. Continuously you are working without giving up. Nice. So okay, so check here once. You can observe. So they mention here 150 milliampere means, so we can, I already mentioned 1 milliampere equal to 10 power minus 3 ampere. Okay, so I is given 150 milliampere, that is nothing but 150 into 10 power minus 3 ampere. And next, so 2 minutes, time is given 2 minutes, so 1 minute equal to 60 seconds. So t equal to 2 into 60, 120 seconds. Okay, now you can, so t equal to 120 seconds. Okay, so we know that I equal to q by t. So 120 seconds, 120 seconds. So that is I equal to q by t, q equal to I into t. So I equal to how much? I equal to how much? I equal to 150 into 10 power minus 3 into 120 seconds. Right? So if you multiply, you'll get 15 into 12 how much? Can anyone knows 15 into 12? 180? Yes or no? 180 will get? Yes. So you can see 180 into 10 power minus 3. So 1 8 10 power 3 10 power minus 3. So Q equal to 18C. Just multiply, you'll get the answer. Yes. If you like the content, do like, share and subscribe to Student the Brand. If you like the content, you can subscribe the channel. So just check once again. Once again check once. A current of 150 milliampere flows through a circuit for 2 minutes. Find the amount of charge that flows through the circuit. So they're asking to find out charge. Thank you. Thank you so much. So expected 1000. So I got 50. Very good. So still we'll fight for the next live. So come and join to the next live. Make me to reach 1000. So we'll reach. So we should not give up. Thank you so much for 50 likes. So you should not give up whatever it happens. So we have to work hard to reach our target. Try, 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 try again and again, again and again, again and again, again and again. You will reach the target one day. ఓకేనా? సో ఒక డైలాగ్ ఉంది ఏంటంటే, లక్ష్యం మీన్స్ fixing the target is not important and reaching the target also not important. For target you will do that right work. That is very important. That is very important. సో ఇంకా గట్టిగా చెప్పాలంటే, నీ లక్ష్యం గొప్ప కాదు, లక్ష్యం పెట్టుకోవటం గొప్ప కాదు, లక్ష్యం చేరుకోవటం గొప్ప కాదు, ఆ లక్ష్యం కోసం నువ్వు చేసే యుద్ధం మాత్రమే గొప్ప. యుద్ధం మాత్రమే గొప్ప. డూ వార్, డూ వార్, రీచ్ ద టార్గెట్. ఫిక్స్ చేసావు, రీచ్ అయిపోయావు, వాటికి అంత ఇంపార్టెన్స్ ఉండవు. కానీ నువ్వు చేసే యుద్ధం ఉంటుంది చూసావా, పోరాటం ఉంటుంది చూసావా, కష్టపడే తత్వం ఉంటుంది చూసావా, అదొక్కటే నిన్ను నిలబెట్టేది. నువ్వు ఏంటనేది నీకు నిరూపిస్తుంది. హర్డిల్స్, ప్రాబ్లమ్స్, స్ట్రగుల్స్, వాట్ ఎవర్ ఇట్ మే బి, వాట్ ఎవర్ ఇట్ మే బి, ఫోకస్, ఫిక్స్ ద టార్గెట్, వర్క్ so hard until you reach the target. Thank you guys, so being with me, supporting me. Thank you so much. So I never forget your support and unmatchable, unbreakable. So no words for that. So keep supporting, keep supporting. Thank you. Okay, so next question. Once again, let's observe here. 1 milliampere equal to 10 power minus 3 ampere. So time equal to 2 minutes, that is 1 minute equal to 60 seconds. 2 equal to into 60, that is 120 seconds. I hope it is very clear. You can see I equal to 150 milliampere. So T you will get I equal to Q by T, Q equal to IT, Q will get. So 18 C. Click on like button if you like it. Right? Yes, one more question. Let's so try this question. One more question. A total of 6 into 10 power 46 electrons flow through a current. So a current carrying conductor, when connected through an external power supply for 20 seconds. Find the value of current in the conductor. Answer. Okay, answer is correct. 4.8 into 10 power 26. So very good. So I equal to Q by T, Q equal to NE. So by using that formula, substitute all the values on 1 electron 1.6 into 10 power minus 19. So here you can substitute I equal to Q by T, Q equal to NE by T on 1 electron 1.6 into 10 power minus 19 coulomb. And so here this is N equal to 6 into 10 power 46 electrons, and T equal to how much? 20 seconds. T equal to 20 seconds. You can substitute I equal to, so 6 into 10 power 46 into 1.6 into 10 power minus 19, 10 power minus 19, 10 power 19 by 20 seconds. You'll get the answer 4.8 into 10 power 26 ampere. So try to solve it. If you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. This is your sir. Thank you so much. We'll see you in the next class. Signing off. Namaste. Thank you.